Hi Math 2 students, this is Miss Van Vickle, and this is your second video on Tuesday, April 21st in our study of exponential growth and decay. And we're going to talk for just a minute about the King's chessboard. The examples on your notes sheet are just a little bit different. It looks like the teacher who wrote this was using a chessboard and nerds to model the grains of rice. But I want to revisit the story. There was a knight that invented the game of chess and presented it to a king. And the king was so grateful that he offered the knight anything in return for the game of chess. And the knight said he didn't want gold, and he didn't want land, and he didn't want fancy things. But what he wanted was 2 grains of rice for each square on the chessboard, and for each square to double those 2 grains. So if we were taking a look at the chessboard, we'd have... There's 64 squares on a chessboard. Chessboard's 8 by 8. And on the first square, the knight was asking the king to place 2 grains of rice, and then double that to 4 grains of rice on the second day, and again double on the third day to 8 grains of rice, and so forth. And he asked the king to do that 64 times over. So the last time we were together on Friday, we kind of talked about this situation together, and we said that what would happen is the initial value, or our starting point, if we look at our function, our initial value was 2, and our rate was doubling, so we would have 2 times 2 to the t power. And instead of time, each unit of t would be successive squares on the chessboard. So if we were to put in 1 here, that would represent going from the beginning value to 1 doubling. So we would have 4 here, 2 times 2 to the first power. And if we were to put 2 in here, that would represent a second doubling. So we would get 2 squared, which is 4 times 2. And we would know that there would be 8 grains of rice on this third square. So it says, using our model, let's predict the number of nerds, which we're actually talking about rice, the number of grains of rice that would be on the 6th square, and we get y is equal to 2 times 2 to the 5. Remember, our exponent's going to be 5 because the 6th square represents the 5th time that we've doubled. So let's see, 2 to the 5th times 2. Let's use our calculator, and we get 2 to the 5th times our initial value of 2, and that gives us 64. So it would seem to be that we would have 64 grains of rice on that 6th square. Then it says if there are 320 nerds or grains of rice on the 6th square, and the rule of doubling was applied, how many nerds or rice were placed on the first square? So what this is saying is we get to square number 6, and we know we have 320. We know we must have started with some other number than 2, because we didn't get 64 like we did up here. And we are doubling. We want to know, let's see, and that would be 5 because it's the 6th square. We want to know what was our starting value. So to find that, we're going to take 2 to the 5th power, which we already know is 32. And then we would divide both sides of the equation by 32. And we would see that our starting value would have had to have been 10 in order to get 320 nerds on that 6th square. So, part D says if you started with 1 nerd, or a grain of rice, and you doubled the number according to the wise man's suggestion, on which square would there be 8,192 nerds? So that's saying that we end up with that many nerds, and we started with 1. We know we're doubling, but we don't know which square number that we're going to end up on. So I really am stuck here because if I use all of my algebra techniques, adding, subtracting, multiplying, and dividing, I can't get that variable out of the exponent, no matter how hard I try. So I always know that when I can't solve an equation by the normal means, I can graph the left side in y1 and the right side in y2 and look for the intersection. So I'm going to graph 8,192 in y1, and in y2 I'm going to graph 1 times 2 to the x power. And I'm going to notice that my y value, my y max value, is going to have to be pretty big right here in order to see my graph. It doesn't look like I need it quite that big. But if I want to see 8,192, I probably should set my y max at 9,000. And I'm just taking a guess that x, 20 doubling periods, would cover it. So let's take a look at my functions as I graph them. And fortunately, I can see both the exponential function and the linear function. And I'm looking for the intersection. So I use second calc, and I want to choose option 5. This is one of the functions I would like to see the intersection of. So I hit enter. And then my exponential curve is the other function that I would like to see the intersection of. So I hit enter again. And when it says guess, I just place my cursor as close as I can to the intersection and hit enter. And I find that x is 13 when y is 8,192. So let's take a look at what that means. If x is equal to 13, that would mean I have doubled 13 times. This is square 1, and then 13 more squares would give me 8,192. So on square 14, I would have 8,192 nerds, or grains of rice, depending on which story you're listening to. So that's it for video 1. Stay tuned for video 2.